Hello everyone. In earlier lectures, we have discussed few simplification techniques. So we will continue with these. We have learned that the objective of these simplification techniques is to have minimum number of terms, and if we have first we reduce the number of terms and then the number of literals. If there is more than one possible solution with the same number of terms, then the one having the minimum number of literals is a choice. So literals means if the variable is in complement form or uncomplemented form, so that is a literal. Suppose a bar. So these are a and a bar are literals, and while a is a variable. A only is a variable, and if it is present as a or a bar in some term, then it is considered as a literal. Now there are various techniques, simplification techniques. First, we can apply Boolean algebra. This thing we have already discussed in previous lectures. Then the other one is Carnot map or kmap method, and the other one is Quinn-McCloskey or tabulation method. Now we have discussed kmap method in earlier lecture also. So few things are left in kmap method that we will discuss today. So we have discussed this thing that while choosing adjacent squares in kmap, we have to ensure that all the minterms of the functions are covered. While combining squares, we have to cover all the minterms. Then the number of terms in the expression is minimized. We have to take the minimum number of terms in the expression, final expression, and there should be no redundant terms. That is, minterms which are already covered by other terms, those should be excluded. So those pairs should be excluded. So when you do follow all these rules, you sometimes find that there may be two or more expressions that satisfy the simplification criteria. Through considering all these rules, you can find two or more expressions that satisfy the simplification criteria. Now, the procedure for combining squares in the map may be made more systematic by considering two terms. So we can, two important terms we should keep in mind. One is prime implicant, the other one is essential prime implicant. Prime implicant is the product term obtained by combining the maximum possible number of adjacent squares in the map. You combine maximum possible numbers of adjacent ones in the map, and those will form prime implicant. Now, what is essential prime implicant? Essential prime implicant means it is if a minterm in a square in a K map is covered by only one prime implicant. If only one prime implicant, one pair of ones cover a minterm, then that prime implicant is said to be essential. Now you can see the prime implicant of a function can be obtained from the map by combining all possible maximum number of squares. You have to combine maximum numbers of squares. That means if there is a single one on the map, so it will represent a prime implicant if it is not adjacent to any other one. That means if a pair is not possible, then only you will consider single one. Then similarly, two adjacent ones form a prime implicant provided they are not within a group of four adjacent squares. So if a pair will be considered if a quad is not possible to form. So similarly, four adjacent ones form a prime implicant if they are not within a group of eight adjacent squares, and so on. So we have to combine maximum number of squares. Then the essential prime implicant can be found by looking at each square marked with 1. That is, in kmap we have if the minterm which is present in the function will be marked by 1. So what we have to do, we have to check each minterm, each one which is filled in kmap, and we have to check that whether the number of prime implicant that cover it. If a square is covered by only one prime implicant, then that is the essential prime implicant. So the prime implicant is essential if it is the only prime implicant that covers the minterm. So to find the simplified expression of a K-map, we can use these implicants. First of all, what we will do, we will uh, we will find all the prime implicants. Out of these we have to find the essential prime implicants. Then the simplified expression is obtained by logical sum of all the essential prime implicants plus the other prime implicants that may be needed to cover any remaining minterms not covered by the essential prime implicant. Essential prime implicant will cover few minterms, so the other remaining minterms which are left, so we have to find the other prime implicants that will cover those remaining minterms, and the sum of essential prime implicant and those other prime implicants form the simplified expression. And you will find in some cases there may be more than one way of combining squares, and combination may produce an equally simplified expression. So solution of a kmap is not unique, we can say. We can have two or more simplified expressions. Now we can let's go through this example so that all the concepts will be clear. So coming to this example, this is a four variable function. A is MSB and D is LSB, and it is sum of these minterms 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, 15. So we will form a K map. It will have 16 combinations because 4 variables are there. So 2 raised to the power 4, 16 squares will be there. So this way we will form the K map A, B, C, D. Then we will put 1 in the minterm box where for which the function is 1. So 0, 0, this is 2, 3, this is 5, 7, this is 8, then 9, then 11, this is 11, this is 11, 13, 15. So 8, 9, 10, 11, 13, 15. So now we will form the maximum number of ones. We will combine maximum number of ones. So this first we will see this one. This can form a quad with these three ones. So it will. If we will write the expression term for this, so it will be B bar, B bar, D bar. Then this one can be combined, maximum is this. So for prime implicant we have to combine maximum number of ones, so we can combine all these four ones, so it will form CD. Now this one can be combined with this one, but the quad is also possible. So first we will form the quad. So this quad is formed, so it will give this will be represented by BD. Then this one, these four ones can be paired together, so these are AD. These will be denoted by AD. Then the this one can be paired in this way also. Four pair of four ones, a quad, so it will be represented by AB bar. Then these two and these two can be paired as a quad, so represented by B bar C. So these are possible, all the possible combinations of maximum number of ones. So this way we can see that the prime implicants we have 1, 2, 3, 4, 5, 6, 6 prime implicants, which are B bar, D bar, CD, BD, AD, AB bar and B bar C. You have to combine maximum number of ones, keep in mind. Then essential prime implicant, you can see this M0, this 0 minterm is covered by only this prime implicant B bar D bar. Then this M5 prime implicant, an M5 minterm, this M5 minterm can be covered with this prime implicant only. Only this prime implicant covers this. Others don't cover this minterm. So M5 covered by BD only, so BD is the prime essential prime implicant. So these two are essential prime implicant. That means in the minimized simplified expression, these two will be there. These are essential. Now we can see that out of these midterms 0 and 5 are covered by essential prime implicants. The remaining ones are 2, 3, 2, 3, 7, 8, 9, 10, 11, 13 and 15. Now out of these also 2, 3, 5, this this essential prime implicant covers midterm 0 as well as midterm 2, midterm 8 and midterm 10. So two essential prime implicant B bar covers 0, 0, 2, 8 and 9, 0, 2, 0, 2, 8 and 10, while BD covers the BD covers this is midterm 5, 7, 5, 7, 13 and 15, 5, 7, 13 and 15. So these critical prime implicants cover these midterms. So the remaining which are left are M9, midterm 9 and midterm 11 and midterm 3. So we can midterm 3, 9 and 11 are left which are not covered by essential prime implicants. So M3, this is M3. So this can be covered by either prime implicant, this is CD, or it can be covered with this B bar C. This is M3, midterm 3. So it can be covered by B bar C or this CD. Then midterm 9 can be covered either by midterm 9 is this one. So midterm 9 can be covered by AD or it can be covered by A B bar. Then midterm 11 is this one, so it can be covered by B bar C. It can be covered. This is midterm 11. This can be covered by CD, or it can be covered by AD, and it can be covered by AB bar and B bar C bar. So it can be covered by any of the four prime implicants. So thus, the simplified expression is obtained by the logical sum of two essential prime implicants and any two other prime implicants that cover midterms M3, M9 and M11. So are four possible ways are there in which this function can be expressed. BD and B bar, D bar, these are essential prime implicant, and these combination of two prime implicants can represent the remaining midterms which are not covered by the essential prime implicant. So we have, if we have CD for midterm 3, so midterm 3 we have CD, and then this AD is for midterm 9 and 11. Then the CD is for midterm midterm 3, and AB bar, this AB bar is for midterm 9 and 11. Then this B bar C is for midterm 3 and AD is for midterm 9 and 11. Then this B bar C is for midterm 3 and B bar this A B bar is for midterm 11. So this way you can see that there are various possible ways in which you can represent this function using the concept of prime implicant and essential prime implicants. So we can the disadvantage of kmap is that it depends on user's ability to identify the pattern. So we have to combine maximum number of ones. So it becomes difficult to adapt for simplification of 5 or more variables. If you have 5 or more variables, then it becomes cumbersome to form a kmap. So for that we will move on to the next simplification method, which is tabular method, which we will discuss in the next lecture. So thank you.